and just leave it.
Little t means transpose, and that flips the rows and the columns.
Wow.
Okay? Now, what does that do in terms of helping us answer this question? Unclear, but that's what transpose does.
Why would you ever need to use this though?
Now we have more access.
Oh,
Wouldn't it, I feel like it'd be easier to explain matrix multiplication first and
Just
then
do it.
What is matrix multiplication?
Just do it.
It's you multiply all of the rows by the columns of the other matrix, add them together.
Oh.
Yeah, that
What
would.
do you like?
Would it be correct to say that a matrix is just a vector of vectors?
Potentially.
Yeah, I'm surprised you don't know.
So what happens if we multiply this matrix by itself?
It's a 2D array.
Somewhere in this matrix, is there a 74?
Yeah.
Yeah.
Somewhere in this matrix, is there a 49?
Yes.
Oh my goodness.
Wait, we didn't need the transpose though.
Yeah, you don't need number line, you don't need translation.
Boston to Phoenix was supposed to be what?
Wait, so you just square the matrix?
Boston to Phoenix was supposed to be how many?
49.
49.
49.
Here's a 49 right here.
No.
What?
No.
What row is this?
Boston.
That was the Boston row. What column is this?
Phoenix.
That's the Phoenix.
It's probably just these numbers.
Where's the 74? Is there a 74 in this matrix?
That's just what matrix is.
Oh, right there. Wait, what was the 74 supposed to be? Chicago
You already know.
to Seattle. Is the third column Seattle? Yes, it is.
So you don't need to transpose anything.
So you don't need to transpose anything.
Wait,
It's the same thing.
Why?
So there's never anything where you just multiply the strings, things in the same position?
No.
Okay.
We can make it up and see what happens. But
So if you want to square the elements inside a matrix, you have to just multiply by its.
It flips the columns of rows. I don't know.
yes.
Oh.
So this is how we define matrix multiplication. You take a row and you dot product it with a column, and that answer goes in the row and column that you picked from the original two matrices. Because here we had the first row, we were multiplying the matrix by itself, so we took the first row and the seventh column, we dot producted those, we got 49, and that answer goes in the first row, seventh column of the answer matrix.
Wait, why did you show transposing, dude?
Transposing didn't do anything, that's just an aside,
Wait, why did you show us that?
because he said transpose, and that's the thing I want you to know about.
That's how we would need to, but we didn't.
Play this. The hidden lessons.
So, how many one-stop flights are there from Phoenix to Chicago?
35.
There should be 35, it's right there,
Wait, no.
okay? So this matrix, the square of the original matrix, this is gonna tell us the number of one-stop flights,
Oh no.
right?
Two stop.
So how would we get
That times itself.
two-stop flights?
Is it this
D
matrix
cubed.
or? No, this matrix.
This matrix squared?
I don't know.
It would be.
Well, we have a way to test this because in the Orlando to Tampa slot, we're supposed to end up with 360.
Yes.
So Orlando to Tampa, Tampa's which column?
Orlando.
No, over
Or
here.
Chicago? You said,
Sophia, you messed him
You messed me
up.
Chicago to Tampa, which one's Tampa?
So, second to last.
I was on a field trip.
The second to last, this one's Tampa? Okay. So, right now we have 0. Does that make sense for, wait, why is that a 0?
Because there's no direct flight. There's
This
no
was-
one
This is
stop.
one stop.
There's no
And how do
one
we get from Chicago to Tampa in one stop? We can't, because you can only get to Tampa from Chicago. So that makes sense. But this is still one stop flight, so how are we gonna get two stop flights?
D cubed.
The original matrix cubed,
Cube.
right? So I'm gonna take this answer, I'm gonna multiply it by, take this answer and multiply it by the original matrix again.
Oh.
So I'm gonna take this. How do I get it to come back? Whatever.
Yeah, just push times.
push times.
Whoa.
You're such an intellectual.
Okay, ready? So we're looking for a 360. Big money, big money, big money.
It's not gonna work.
No whammy, no whammy, no whammy.
Yeah.
Wow.
There's two 360s.
Wait, wait.
Oh my god. Whoa, where do you see another 360?
How do I arrow over there? It says there's an arrow. How do I see
Go
it?
to the back.
Can't.
Hit enter.
Press enter.
Press
You
enter.
literally
Already
can't.
over.
It's the most annoying part of these calculators.
Literally can't get it.
I
Well, now
never
you-
found a way.
Well, that's not the right matrix anymore.
That's the next one.
Wait,
Wait, it's still a zero?
Wait, what happens if you hit enter?
Hold on,
Nothing.
hold on, hold
I
on.
guess we're gonna
There's
have to
absolutely
finish
nothing.
this class.
You have to, your calculator actually has like a tilt function, you have to
It's like
No, it's
tilted
like those
piece.
Oh my god, that works.
You like hold it up to your face and you like look around at the matrix.
Isometric projection.
Wait, how do I get over
You have to
there?
plug it into your computer and see
Yeah.
it.
You can't?
Wait, no, but
You're
that's
sure
all set.
it
You
was
can actually see all of it.
We'll try so there's.
1, 2, 3, 4, 5, 6.
That should be
Three,
all.
yeah, right, yeah, there should be a 360. That is all of it.
There are
Okay,
two.
like, where did it go?
Sometimes
Why
it's
is all
all-
spinning
Yeah, didn't give us like 30 seconds.
Is there a 360?
There's two.
Oh, look at that. Is that in the Chicago to Tampa spot?
Yes.
Heck yeah, it
We
is.
should take it from you, salad.
Wow.
You teachers take a lot of money.
Now, in this case, it happens to be symmetrical. Why does that make sense?
Is there something
There's only one way.
Which one?
If we're going from Tampa to Chicago, that turns out to be the same answer. But that should actually make sense based on the graph, right? Because if we're going from Tampa to Chicago in 2 stops, we start in Tampa, where do we fly? Chicago,
Oh, yeah.
and then to do it in 2 stops, we have to go somewhere else and then go back to Chicago. So it turns out to be the same problem. So it should have the same answer, which it does based on the matrix multiplication. Okay? Yeah.
How would you say this if you're not talking about airports? Like, not just 2-stop flights, like what would that be?
So it depends on the context of what you're talking about. And now this is also a little bit different because what we're ending up doing is we're multiplying a matrix by itself. Right? So we're not always going to be multiplying a matrix by itself. We could be multiplying the matrix by something else.
That's how it
Right?
always is in the beginning.
Like this one right here.
Oh, I thought I did that one.
Yeah, oh, and what's up with this? So much for the class participation points.
No.
Oh, but it's chapter 4, so it's fine. It's not, we're not done with that chapter yet.
We didn't do
You still have time, Owen.
All right,
Now.
write A and B in terms of X and Y. So here's A. A is 3m plus 2n plus 4p. B is m minus 4n plus 6p. And here's m, n, and p. Now, so if we want to know A in terms of X and Y,
3 times 2. 3 times 3.
how many x's do we get from the m?
Oh, this is the
2.
same thing.
Oh,
Oh my god, this
Oh,
is
no.
because we would take the 3 times the 2, right? If we're counting the x's for A is going to be how many x's? Well, from m we're going to get 2. From the n's, how many are we going to get? 8. From the p's, how many are we going to get? 4. And then what are we going to do with all those numbers? Add them together. Oh. So I could turn this into a matrix. I could say 3, 2, 4, 1, negative 4 is 6. And I could multiply that by what?
Oh. 2, 3, 4, 9, 5.
If we multiply these matrices together,
Wonderful.
okay?
Wonderful.
Can you show how they match again with the arrows?
So we're gonna do first row dotted with first column, right? So
Oh,
6 plus 8 plus 4.
have you seen that meme where it's like
It's
outstanding
18.
with this escalator?
And since that's the first row, first column, I'm gonna put it in the first row, first column. And we're gonna do,
It's in a building.
and we're gonna do first row, second column, which would be 9 minus 10 plus 40. So that would be 39.
How do you do that so fast? I can't do that.
Right?
It's whack.
And we're gonna do,
I really wish someone had taught me this in pre-calc.
and we're gonna do second row, first column, dot product, so that's 2 minus 16 plus 6, so that's -8. Okay. And then this times this, so 3 plus 20 plus 60 is
You gotta work on the
83. So A is 18x plus 39y, and B is -8x plus 83y.
So you literally foil the matrix,
Nice,
but not foil.
Mr. Rubric,
It's not foil, don't, I don't, it's not foiling,
No, it is foil.
no, no.
Mr. Ricky, why in the first 18 is it a regular rate, but everything else is 2 seconds?
Consistency is the hobgoblin of small